Okay, let's take on the second part of this lesson. It's very conceptual. We're going to take on something called energy conversions, or the changes in energy. And from this formula here, work is equal to change in energy, you can see that if work is done in an object, its energy is going to change in some way. And there's really two different ways that energy can actually change. The first one, the word we use, is a transformation, where it changes form from one form to another. So for example, if you have this object here kind of flying freely upward to a maximum height, at the beginning you'll see that it has speed, and that would be kinetic energy. And you can see that in the end, it slows down until it has no more kinetic energy, but then it has just potential energy. And we say the kinetic energy converts to potential energy. That's called a transformation, from one kind of energy to another. This one is due to the work done by the force of gravity. The other type of change that can take place is called a transfer. This is going from one object to another. So I have an example here of a car coming in, and you'll see that it comes in with a lot of energy, and the object 2 doesn't have any. So here's object 1 and 2. 1 has all the energy, but in the end, we can see that they're both moving. So energy is actually transferred from 1 to 2, giving it some kinetic energy. So that's called a transfer. And when you're dealing with conversions, you have to be able to deal with both changes in form and changes from one object to another. So keep that in mind. Anytime we talk about energy conversions, I want you to think about the word changes. We're looking for how the energy changes. And you need to figure out changes in energy and changes in objects. From what energy to what energy? So energy to energy, object to object. So what I'm going to do for you here is I'm going to illustrate with the trampoline, and then I'll give you guys a chance to try one on your own. So we have a diagram here of a person going from maximum height and falling down towards a trampoline. And we need to do the energy conversions. So again, remember, anytime you think about conversions, you're going to think changes from one to another. To help you with this, I'm going to show you a technique that students often enjoy. What we do is we're going to do box to box, if you like doing this. And what you have to know about these two boxes, the first box here is the energy that decreases, whereas the other side is the energy that increases. So let's take a look at the first part of the motion, which is when you're falling towards a trampoline and you're just about to hit the trampoline at the end. Now, can you see that as this person's falling, the person's height is decreasing? So the height is decreasing. What's the energy due to height? Well, that's potential energy. So that means that's what goes into the first box here. So this would be potential energy. And then you have to be aware, remember that's energy, and also to figure out what object has it. And this would be potential energy in the person. So the person has potential energy at the start, if you wish, but that's what energy is decreasing as you fall, as a person falls down. At the end, for what increases, well, we can see that the speed is increasing. And speed is kinetic energy. So that's what goes into the second box. This would be the kinetic energy. And the object, well, it's still in the person, which means there's no transfer. It stays inside the person and just goes from potential energy to kinetic energy. So from what decreases to what increases. Good, that's our first stage. Next, let's talk about landing on the trampoline. So you're landing and then you stretch it to a very low level underneath. And we'll do the exact same procedure. So we'll do box to box, remembering that the first one is what decreases and the second one is what increases. Okay, so first of all, you'll notice that this person's, if we think about the height, you see how the height is decreasing. So definitely there is a decrease in height. But notice also the speed goes from maximum speed to come to rest. So the speed also decreases. That means at the beginning here, there's both potential energy and kinetic energy. And both of these are in the person. But where do these energies go? Because they're decreasing. Energy cannot be created or destroyed. Well, the increase, logically, is like stretching that trampoline. So it stretches the trampoline. And so that is a spring energy. So this represents spring energy. In what object? Well, now it's in, we can just say the trampoline. Whether it's the material or the springs on the side, whatever it might be. But I should let you know also that you're likely going to be losing quite a bit of energy due to heat and sound. So we can put over here, heat and sound are likely going to be significant losses as well. So not all of it's going to go to the trampoline. Some of it will be lost, realistically. Good? So this is the procedure for how to do conversions. Your turn. So what we have now on the top here, you have this example in your workbook. We have an object that essentially what happens is this, we have a compressed spring, and it's going to launch this object up to the top of a ramp, go flying through the air, and it lands in the water. And your job is to figure out, if there's no friction or air resistance all the way through, what are the conversions for each stage? And I've kind of listed all the stages for you. I encourage you guys to try this question yourself first, and then see how you do. So just pause, and then we'll take it on. Okay, let's take on the first stage here. So we'll do box, which is your decrease, to box, which is your increase. In this case here, you can see there's no doubt that as this object kind of goes up the slope, the height is increasing. So I'll just kind of put that over here. There's a height increase on this side. There's also a speed increase on this side. So on the right-hand side, we can see that we have both potential energy and kinetic energy, and they're going to be in the object, that block there. So that's what energy is produced. But where did the energy come from? Well, logically, it comes from the spring itself. So that would be spring energy in, logically, the spring. So we have a transformation from spring energy to potential kinetic. We also have a transfer from spring to object. Energy to energy, object to object. If you guys did this alone, awesome. Okay, that's a very important one. Next, now it becomes a projectile, and now it's flying up to maximum height. And what I need you guys to make sure you don't do in this one is just to simply identify the energies before and after. Please don't write this down, but I've had people say this, okay, at the beginning it has speed and height. So it has kinetic and potential at the beginning, and at the end it has speed and height. So kinetic and potential. And realize what you're actually saying. If you think that this becomes this, remember, on the left-hand side is what decreases. What's on the right-hand side is what increases. which means you're telling me that kinetic energy is decreasing and increasing. That makes no sense. You can't have the same energy slash object on both sides. That doesn't make any sense at all. So you're not just listing the energies it has. You got to make sure that what's on the left is what decreases and what's on the right is what increases. Really important. So let's now do that one. Okay, so remember, what is on the left is what decreases. Well, if it's flying up to maximum height, definitely the speed will decrease. It's going to slow down as it goes up to maximum height, and we know the height increases. So we can say that the kinetic energy in the object converts to potential energy, and it stays inside the object. There's no transfer here. Good? What decreases on the left, what increases on the right. Then it falls back down. We can do this one quickly. It's simply the reverse of the previous one. So now the height decreases, so potential energy in the object, and the speed increases, converts to kinetic energy in the object. Okay, so just the reverse. And then we get to a kind of a little cute, playful one where it actually hits the water. And the idea here, we know that when it actually hits the water, there's going to be a small decrease in height, a little bit. So I'll put that in brackets. It's minor. But there's a huge decrease in speed, for sure. So for this one here, no doubt the biggest one I'm expecting to see is kinetic energy. There will be a small potential energy. I wouldn't expect you to write it, but if you did, that's good, in the object. So that's what's going to be decreasing here. What does it convert to? Well, have a little bit of fun with this. We know this one here is going to be creating waves, so we're going to get wave energy. There's going to be splashing. So that would be kinetic energy. There would probably be also some heat and sound when it smashes into the water. You know what, as long as you show some logic on this one, we're okay. But it's going to create waves, and it's going to have splashing, so that's kinetic energy inside the water, that's primary. And then there would be some heat and sound loss. Good. This one, you just got to use your logic, and then you're on your way. All right, I hope you found that enjoyable. I'll see you guys in the next lesson.